So today I wanted to go over that homework assignment, the house, and talk a little bit about some nuances. It's actually inside of Dr. Java, and in particular, nuances in general about coding when you're dealing with characters. And we're going to continue with escape characters. By the way, I just figured I'd throw this graphic up here. This is the actual journal entry from the bug from Grace Hopper. This was her entry into where she found the computer bug. So I thought it was kind of fun. Nice archive picture there. There we go. So let's take a look at this real quick. Oh, this was the exit ticket, isn't it? This is part of it. Or is it? No, it's not. All right, take a look at this. Tell me what is outputted by this statement. I'm going to pause and let you think about it for a minute. So what we have here is quotes, a new line, and then a single backslash, 2 forward slashes, and then another single backslash, right? And then underneath of it, what do we have here? Anything special here? No, just prints out 2 vertical slashes. I had to complete the picture, so when we look at the picture, we get something that looks like this. Recognize it? It's an artistic rendering of a horse. I know, you got to really take a lot of artistic license on this one. But, you know, we got the 2 floaty eyes up here. Okay, a sheep? I don't know. Maybe a camel. A giraffe. Really kind of go artistic on this one, but yeah. So this brings up the question, and I kind of did this way to be silly for a reason. Character graphics are really awful. Doing graphics based upon characters is a horrible, horrible way of actually doing graphics. When I was younger, back in the day, before the internet, we used to have these things called bulletin board systems. And bulletin board systems, they had lots of games on them. One of the games that they would play a lot of times is like a choose-your-own-adventure game, where you would go through the story and see all these different things happening. The only way they had of doing graphics was character graphics, and people would get really, really proficient at putting together different symbols and shapes from the Unicode character set to get really cool pictures. But they were always, you kind of had to squint a little bit and step a little bit back from the stage to kind of figure out what was going on. It wasn't like graphics that you guys have now, where you have images that are either set up pixel by pixel, or if you have a good enough parallel processing graphics card where it shoots out huge blocks of pixels at once. Great video. Maybe I'll post it in Blackboard that Mythbusters did about explaining the difference between single pixel graphics cards and parallel processing graphics cards. They painted the Mona Lisa in under a second. It was really pretty cool. So I'll post that into the Blackboard. So the other issue with this is a lot of it's dependent upon the computer. The resolution of the computer screen, the font that the computer is using to display the characters. So some of you may have had the issue, some of you did not, but some of you may have had the issue in Dr. Java where you couldn't get your pictures to line up right. So your house may not have looked like this. Your house might have been slightly shifted. So you have to go in and change the font so it matches the same font as this was designed upon. So that's the kind of trick. If it didn't line up, you have to go through and change the character spacing. So when we look at this, you see when I first did this, the font didn't line up. How many people ended up with something like that where it didn't quite line up? Right? It was off a little bit. And then you tried to mess with the spacing a little bit to kind of get it to spaced out. And mine actually is supposed to come to a peak. So some of you kind of fudged it and made it have like a wider gap at the top. And that seemed to work and get the house to work. But it wasn't the original design. The original design was this. So you kind of made it work, which was fine for this assignment. The way to fix it is to change the font to Courier New. That's the way you fix it inside of Dr. Java. You want to make sure that the font is Courier New, so you go up to the preferences and you find the font and just change the font to Courier New. Courier New, not Courier New. That would be an interesting font. It's all about horses. The Courier. They shoe horses. So when you change that and run your code without modifying with weird spaces, it runs just fine. So when you guys do the circle one, if you change the font, you won't have to mess with spacing all that much. It will become a lot easier for you. Some of you who went ahead and did the circle already may have found that, yes, you really have to kind of mess with the spacing to get it to line up the way you want it to line up. So that was why I didn't want you to go ahead. I wanted to make sure you had this information before we went any further. Yeah. So now when you run it, same code, but the effect is it works just fine. Everything lines up perfectly. And that's because of the way the fonts are done in Courier New versus some other fonts. An L, the character spacing for an L in Courier New is the same character spacing as for an A. They give the same amount of block size. But in a lot of the other fonts, they actually change the block size. The space given for an L versus an A in Times New Roman is different. That's why a lot of times when you look at Courier New, it kind of looks really expanded out. Right? It looks like it's taking up a lot of extra space. Well, it's because it is taking up a lot of extra space. It's giving each block a full character width. Each character, is getting a full block. Whereas in Times New Roman, it's more dynamic. And a lot of the other fonts are more dynamic in the way they pick and choose the size of the characters. So if you're doing character graphics and you're kind of doing like a block system, using some font other than Courier New could be problematic because you'll have some letters that are smaller than other letters and it'll shift over your image. Things won't line up right. So that's why you would do it in something like Courier New. So comments in Java, I talked about them briefly last week. I want to talk about them again this week. Comments are really important in your code. They're important for you. They're important for other people to look at. There are a couple different ways of doing comments in Java. This is one of them. Now, anything that is behind these forward slashes will show up as a comment as long as it's not in quotes. If it's in quotes, Java treats it as any other string. Looks at forward slashes is fine. That's not an escape character sequence. Outside of quotes, it reads it as a comma. A comment. Other uses for comments are, suppose you have a whole bunch of code and you're trying to find a mistake. Well, one thing you could do is go through and comment out lines. Rather than deleting the lines of code, you could put comments in front of those lines of code, and Java will ignore them. So you could really focus in on piece by piece where the issues are in your code and find the mistake. Or I know in some of my games that I've been working on, I have an autoplay where the game just plays itself. I don't want to leave that in there because that wouldn't make a very fun game for people. You go into the game, it plays it by itself. But I want to have the option when I'm testing it, so I don't want to delete the code either. So all I do is I comment out the call to the autoplay function. So it doesn't do that part, but the command is still there. So the program just ignores it. So that way the comment's there. I put other methods in there that I might have for other debugging things that are built in. Again, I don't necessarily want to delete them in case I have some other reason to go back and debug it. I don't have to go back and recreate all of that. So it's just commented out. So it's a good way for debugging. It's a good way for testing. It's a good way for leaving landmarks. Java allows you to put comments at the end of a line. So you could do a system.out.println, quotes, hello world, quotes, semicolon, and then put a comment at the end of the line. Don't do that. It's really bad stylistically. Just because you can doesn't mean you should. Commenting at the end of a line is bad form. One, because it's really hard to read. It's hard to see where that comment is. Why not just put it above it or below it? Two, normally comments are for sections of code, not single lines of code. So you don't want to comment just on one line, unless there's some really good reason to do that. And if there's a really good reason to comment on a single line, then yeah, put it at the end, because it should just be about that line. But typically it's about an entire block or an entire program you're putting those comments in. Is that clear? Now, if you had multiple lines of comments like they have here, putting those forward slashes in for every single line could be a pain. Yeah. So there's a way of commenting that you can comment an entire block without having to put symbols in front of every single line. It's a /**. And then anything that follows that, no matter what line it's on, will be a comment. To end the comment, you put an asterisk asterisk //. And then that will allow you to do an entire block of comments, multiple lines, formatting stuff, without having to put this symbol in front of every single line. That commenting style, I don't believe, is on the AP exam, but it is very useful for programmers, especially in the very beginning of a piece of code, because you have lots of things to say in the very beginning, and putting this on every single line would be problematic. You could do one huge long line, but it kind of defeats the purpose of doing comments at that point because it's unreadable. Yeah? Before the quotes. If you want to print out a quote, it's a backslash. So it's /quote will print out a quote. 2 forward slashes in front of, outside of the quotes. If you put it inside the quotes, it becomes a string. Java just looks at it as a string. If you put it in outside the quotes, anything that's outside the quotes will be a comment. Does that make sense? Using that other comment notation, the /** is also a good way for code blocking out large sections of code. Rather than having to go through and hit every single line, you could do /*, scroll down, asterisk // and that blocks out an entire piece of code. Like a whole for loop or a whole while loop. You don't have to worry about doing every single line, because that can be very tedious, and then could also lead to errors later when you try to undo it, because you may have missed a comment and something, it just can be a mess. So that's a good, useful technique of using commenting out for large blocks of code. So you might have a command that you want to save for later. Like you're not ready yet to use that command. Or it might be an entire function or subroutine. It hasn't been written yet, but you know that's kind of where it's going to go. So you can use comments out for that. Leaving notes for yourself might look something like this. This is where I left off. I need to finish this tomorrow, so you know where to be picked up. If you have a command, you need to take out the // to run the command. So if we take out the forward slashes, we can see that command now runs. The color changes in the IDE. It's one of the things that are nice about Dr. Java. Yes, it doesn't do caps and all that, but it does change colors to let you know that you're on the right track. You will not have that option on the paper pencil test, though. It won't change colors on the paper. That would be really impressive if your pencil just changed colors because you put 2 slashes in front of it, but it doesn't do that. Maybe someday one of you guys will make that. And here is that forward asterisk, backward asterisk. It blocks out the entire section of code for you. So you don't have to do that //. So when you run this, you get nothing. So last thing I want to talk about today, there's no really good place to talk about this, but since we're starting to get into actually running programs, I wanted to talk a little bit about how the Java compiler really works. And what is a compiler? I've thrown that word around. And how does computers really behave? Well, we kind of have to go back to Grace Hopper a little bit. Grace Hopper designed a language. And you might all be kind of questioning, what does that mean? Well, before that, in order to get a computer to do something, you would have to type in a series of numbers. The numbers weren't the numbers that you guys are used to, like 1, 2, 3. The numbers were hexadecimal numbers. It's just a different numbering system. Base 16, we go 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. That gives us the ability to use less characters to make bigger numbers. Fits nicely inside of computers. Computers work on 8 bits. Hexadecimal is 16-bit. Divisible by 2 makes it really nice and lines right up. Because computers work with ones and zeros. Flipping a switch, on and off. Hexadecimal takes a whole bunch of those ones and zeros and puts them together. So you would take a computer and program it with switches, ones and zeros. In fact, when I was younger, in high school, I had a great teacher who had all these really cool older computers, and I worked on something called a PDB-8, which was totally in binary, and everything was switches. And you would code your line of code with a whole bunch of switches, press and enter, then code the next line of code with a whole bunch of switches, press enter, and the entire computer would be programmed with ones and zeros. And then we were so excited because we got hexadecimal, which was a keypad that was about 3 inches by 3 inches with just letters and numbers on it, and we would type in letters and numbers to write our code. And that's how you programmed. But unless you're really into programming, that's really hard to do. Very tedious. So Grace Hopper said we need something that allows other people to code who are more experts in the field. Programmers are programmers. They're not necessarily experts in the field of business or in the field of accounting or the field of medical science. So they needed a way of bridging that, so they started coming up with computer languages to allow more people to understand what was going on in those languages. But the computer still understood what's called the machine language, the ones and zeros. So they needed a bridge that could go from the language to the ones and zeros. That bridge is called a compiler, where it essentially is translating a language from one language to another language. There are multiple levels of compilers. Some languages get compiled twice, where it goes from one language to another language to assembly language. Some languages get compiled once. The languages that get compiled once run faster than the languages that get compiled twice. The languages that don't get compiled, that are all straight machine language, run even faster. So that's why when you get a game for your PSP or your Xbox, they do it on the PSP too. It's the little cards. I know what I'm talking about. So there's a PS4, and that's the expensive big one. I bought for my son, and he plays, and I never get to see. But they compile it into binary machine language, and that's why it runs so well on your computers. But you can't just like open up a text file and read the code. That won't work. It's all numbers. It's all ones and zeros. So we have our high-level languages like C and PHP and Perl, and they get compiled into a machine code or assembly language, and the machine code is platform dependent. So you need a compiler specific for your computer. So you have a compiled version for the Xbox One that's different than the compiled version for the PS4. Same game, should play exactly the same, but they're totally different. They will not run on the same platform because they're compiled. So Java does something a little different. Java does this high-level language and then compiles it to bytecode, which is platform independent, which means any computer whatsoever can compile bytecode. Then Sun Microsystems came out and said, we're going to give a compiler for every platform, Windows, Mac, and Linux, that will compile bytecode into native machine language that the computer will understand. So the programmer only halfway compiles the code. They compile it to bytecode. That's why when you go to a website that has like a Java applet, it has to load. It's actually doing part of the compiling. Whereas if you open up your game, other than graphics loading, your game on your PS4 loads really fast. Except for some of the graphics rendering. But the game itself starts up. You don't have to wait for a big long loading screen for it to actually finish compiling. But if you're playing a web game, it has to load. And it's getting faster, but it still has to load. It's still compiling on your computer. That's why you have to give permission to allow Java to run on your computer. The website is using your computer resources to actually run the program. It's not running on their server. So you have to give permission for that to happen. You have to enable Java. Most computers come with Java enabled. Sometimes you'll come across a computer where people are afraid of the internet in general. So they have security set up at such a high level that it won't run. So we have our second compiler, which then compiles either to PC, a Mac, or some type of Linux-based system. Windows OS, whatever we have. Maybe we'll have Windows 1 devices, which are different, Chromebook devices. I mean, all these things compile differently. That's why Java didn't work on Chrome for a long time, the Chromebooks, because they didn't have a compiler for it. There was nobody wrote one yet. So you now should have enough information to do the try to circle. Should have gotten feedback from me about the house if there was a problem. A couple of you did not upload the .java file, so make sure you do that and resubmit. You can always resubmit these assignments. There will be another video in addition to this one about comments if you want to rewatch that video. And then there's this little quiz, the escape characters quiz. This is a formative assessment exit ticket that I expect you guys to work on. Most exit tickets will be worked on during class time. They're not meant to necessarily be done at home. Sometimes I'll give them to you at home, but most of the time I'm going to give you class time to work on it so we can kind of sort out any questions that you might have. So we have like 10 minutes. That should be enough time for you guys to get through the exit ticket and then have time to ask a question about it if you want to. So go ahead, work on the exit ticket, and if you have a question, send me an email and I'll send you a message.